Rajat and George, thanks very much for joining us on AU Manufacturing Conversations. It's a pleasure to have you both on the program.
Lovely to be on here, Brent. Looking forward to it.
Thanks for having me on, Brent. Really looking forward to speaking to you and your audience today.
Quite all right. So let's get started with the generic opening question that I ask all our guests, as I find it's a nice way of giving everyone a bit of context. So tell me, guys, how did you get here and what do you make?
Why don't I start with that, Raj? So how did we end up being here at this time? Many years ago, I was running a retail technology startup, my second one. The first one was a travel technology startup that we had a reasonably good exit on. And then I got into retail technology and I needed a new chief technology officer, needed someone who really knew exactly what they were doing and could execute, had the right mindset. So I actually got a recruiter to execute a global search. And I still remember this moment to the day. I got on the phone with Raj. He was in Boston at the time. And I started talking to him. And about 10 minutes in, I'm like, yep, that's the guy. He's the one. We need him. He then ended up, after we ran the process, we recruited him. He moved back to Australia. We started working together in 2014 on this retail technology company. Worked on that for 3.5 years before we decided to stop it. And then, Raj and I kept working together and have been ever since. It's a great story and I love working with him.
Wonderful. Well, it sounds like you got quite a bit of warmth there, on personal and professional level. And that's obviously a good place to get started if you're going to get into business together. Raj, are you more from, I guess, I read some way that you studied aerospace engineering. So is space kind of something that you've been in love with for a while? Or tell me about your path here, please.
I actually moved from India to Australia back in 1996. I was doing systems engineering at ANU, and in the second year of the program, I wrote a paper which got published later on, missile guidance, and my professor said, why are you doing systems? Why don't you go do aerospace? So moved to Sydney to finish the aerospace degree. Came out and, dot-com boom was on. There's not a lot of space jobs at that time. And so spent a lot of time in software. And so was at Microsoft for a while, was their CTO locally, also ran Microsoft research in the region, and then caught the startup bug. And so one of those startups that I was working at back in 2014 is where I bumped into George. And so I was looking for an opportunity to come back home from the US. And, I got on the phone and the experience was very similar. As we had that first conversation, I'm like, that's the guy. I think what I have realized over the years is that when you're doing startups may succeed or fail, but you work with people and people you want to spend that much time with. So I think it's super important how you choose your team and how you choose your co-founders.
For sure. So tell me about getting started with Space Machines Company. Was it a context where you saw a big problem that you guys thought you were well positioned to address via whatever means? Tell me about the origin story, please.
Can I start that one, Raj? I love telling this story. I can remember it very specifically. It was October 2018. I was sitting on my couch having a glass of red wine. I live in Adelaide. It's pretty standard. And I get a call from Raj. We're always talking to each other about ideas. He's like, George, we need to build a space company. I'm like, what? A space company? I've never thought about space. And he's like, no, I think we should build a space business. I think space is changing. There's huge opportunities coming. It's incredibly important. And I think that there's a really good opportunity to build a space company. I'm like, sure, I'm in.
I see. Well, that's a very general way to get started. You want to do a space business and you decide to. Is that about the beginning and end of it?
Yeah, no, look, I think that conversation was quite important because I think what it helped us solidify was that there was an opportunity. And then when we looked more deeply into the problem, what we were noticing was that with SpaceX and some of the other launchers, the cost of getting to orbit was going to be exponentially reduced, which means there are going to be a lot of things going up in the next, at that time, 5 to 10 years. And I think since then, it's already gone up 6 to 8 times. And with that is going to come the fact that the cost of operating in space is still high, which means if you've got more and more stuff going on, you're starting to create debris, you're starting to put critical infrastructure in orbit, you're starting to think about things that we depend on Earth into orbit because now it's cheap to do that. And with that came the fact that if you could not very easily maneuver in orbit, that was going to be a problem. And so for us, the very first challenge we took on was, how do we really think differently about maneuvering in space? Because that leads to security, that leads to sustainability, that leads to overall economic growth coming from the space economy. And so I think our view was very, very quickly starting to focus on maneuvering rapidly at low cost in orbit. That was the crux of the problem and remains the crux of the problem in the thesis for what we do.
And so the main thing you're doing to serve that end is making something called Optimus Viper. Tell us about what the current iteration of the vehicle can do, and I guess a little bit about the upcoming mission with MAITRI, if that's how you pronounce it.
Yep, and George, jump in when you see me leave out some important bit. The way we thought about solving that problem was the only way to get really a good understanding of what was happening with a piece of critical infrastructure in orbit was to be able to, one, respond when it was under threat, right? Whether it's catastrophic failure, whether it's bad actors, whether it's adversaries, if there is a threat to your space asset, can you get there very rapidly? Can you get there at low cost? And can you get to all of the assets out there that you depend on? And so to solve those three problems, we came up with a system which was a hardware spacecraft, an actual spacecraft. Think of it as a first responder. It's a 200-kilo spacecraft carrying a lot of maneuverability on it, a lot of sensors on it, can very quickly respond in orbit, is low cost. And so Optimus Viper for us was that spacecraft. It's a 200-kilo spacecraft that carries optical, infrared, LiDAR sensors to get very close to an asset, understand what's happening with it. And to make that work for customers, we then have an AI-driven software called Solstice OS, which basically allows us to control a number of these vehicles, these rapid response vehicles in Viper. And that way they can address that last piece of giving coverage where we can get to every asset. So the idea that you have a software-enabled hardware system that can very quickly get to where there is an incident, where there's a threat, and sort of address customers' use cases. George?
If I can build on that, imagine what it would be like on Earth if a first responder to an incident cost millions of dollars to get there. You wouldn't respond. And, tying back to sort of right at the beginning, I was a bit flippant about the founding story, but, over the course of time, I've become very purposefully attached to the importance and impact of what we're building on orbit, because orbit requires a cost-effective, rapid ability to be near objects of interest, whether those objects are adversaries, friendly satellites, space junk. If there is a very, very cost-effective and fast way to be nearby to them and then be able to inspect or affect them in a way that helps to safeguard space, that is an incredibly positive outcome for the security of our planet, the future of our planet, and then what we have as we move into potentially, occupying space, the moon and beyond. So it's a very, very important capability. And it became clear to us that there was no spacecraft purpose-built for mass manufacturing that could meet that need. Probably about 18 months ago. And I think Raj articulated nicely how Viper fits that opportunity really neatly.
So you've successfully launched Optimus, but you lost contact with it, obviously. Tell us a bit about that maiden launch, what you learned from it, and how it's informed what you've done since.
Yeah, look, sorry, go ahead.
You want to take that one first, Raj, and then I'll jump in?
Yeah, of course. So look, when we started building the Viper, or the first iteration of Viper, it was the first time a team in Australia was going to build a 250-kilo satellite. And so when we set the metrics to ourselves, for us, mission success was built in this sort of arrangement. 95% mission success if we got to the launch pad. Another 3% if we got to orbit, another 2% if it did everything, because where we were coming from, a small group of engineers in Australia, not building a 3U, 6U satellite, but trying to build a small satellite on the ground here, for us, that in itself was massive. Now, when we got to orbit, we struggled to make contact for a long period of time. And that was driven by a couple of things for us. One was there was some things that happened as far as the deployment is concerned, where it took us a long time to identify whose object was whose, right? There were about 53 satellites on that flight. So I think we have a lot of learning as far as satellite operations, post-launch operations, and how do we harden our communication? How do we harden our procedures, post-launch procedures? How do we go back and create more redundancy in the systems? So I think since then, the teams, obviously, they wanted the whole 100%, not the 98% success. And so we took our time. We went back to the drawing board. We started thinking about how we improve the next version. And a lot of those learnings are now being applied to the next iteration of the spacecraft, which, as you pointed out, is going to be flying on the Space MAITRI mission. George.
Look, I had the great privilege of being there at Vandenberg for the launch of Optimus and was with many sort of space industry people and reflected on, some of the other companies that were there at the same time and the amount of funding that they'd had. And I think what we should, and the team particularly, should be incredibly proud of is that on a very tight budget, we built Australia's largest single spacecraft and got it into orbit. And, the outcome of that is belief, right? What that does is it helps our team, investors, the country believe we can build something like that. Much like Gilmore's successful launch to get off the pad this year builds belief. And I think that we now believe we can build a spacecraft like that, and others do as well. And that has an incredible impact on the overall journey. And as a non-space person, what really surprised me, there was 50-odd spacecraft launched on that ride share, and I didn't really understand it. But today, I think there's still 20% of them are still not ever talked to. So that sort of rate of uncommunication or not being able to communicate with them really did surprise me. But it's normal. And it's a really normal thing that you launch your first spacecraft, and if you're doing it on a tight budget and fast, it may not work, but you get a whole lot of learning and belief out of that. So I think it was a great milestone for Australia, a great milestone for our team, and I think it did increase the belief of the overall space industry in Australia.
Spot on.
Yeah, sure. And so that's a bit about what Optimus has done before and what it can do and what you're looking to do with it. Let's look at now how it's put together and some of what goes into that. And tell me, please, about the supply chain. You're working with a bunch of Aussie companies, I would guess. Could you say who contributes to one of your machines?
Yeah, look, I think maybe we take the example of the Space MAITRI mission, and you sort of raised that earlier in the talk. So our next mission is flying from India on an SSLV rocket as part of a program that was partially funded by the Australian Space Agency. And the objective of that program is to really start building collaborative network between India and Australia on supply chain and on space heritage. And so for us, when we think about supply chain, there is our supply chain, which is parts that go into our own spacecraft. And so we currently, as part of our efforts, vertically integrate a lot of it, but then we also work with partners in Australia, partners in Europe, partners in India. We are targeting that by the end of the third mission, we should be able to get up to 70% Australian content, which will be a massive victory for us, because at the end of the day, we want our supply chain close to where we are building these spacecraft at scale. Now, when we think about partners on this mission, we think about companies like HEO. We're thinking about partners like Advanced Navigation, and we start to think about companies that are providing fasteners and machining in New South Wales, for example. So there's a very large group of companies, everything from logistics, building the satellite box, to sensors, to power systems, to machining, to 3D printing, that form a very large group of companies, more than 50 at this stage, that's locally provide us that support. But then when we think about partners, universities, HEO, we're working with Indian partners on this mission, providing similar capability. So I think with our first mission, we carried last year, actually 6 companies from the local ecosystem: Spiral, Esper, HEO, Dandelion. So I think for us, the philosophy always has been that our core strength in Australia, we will never have as much capital as is available to the US space sector. We will never have the low-cost manufacturing base. But what we do have is, and our superpower will have to be working together collaboratively with the supply chain and the ecosystem that is there here today. And so for us, finding more and more companies that we can work with that can supply different parts of our system. And in doing so, we lift the entire space ecosystem to where we need it to be. And so I think partnering with space companies here, but also working through the local supply chain is probably the biggest superpower we have at the moment.
Right. That's something that warms my heart to think about. And another thing that sort of made me go, wow, this is a nice anecdote and it shows what can get done here by thinking out of the box was an anecdote from a story you guys had written. And this is regarding your insulation blanket for your first Optimus. You wrote, we had to think outside the box. And that's when we brought on industrial sewing machinist Philippe Vincent, who usually works on violin bags and fashion, to hand sew the blanket. And I thought that was really cool. Do you have any reflections on that right now?
I think when I reflect on that, I think that is just this intentful way of thinking about solving a problem. And I think it's inherently Australian. I think somewhere along the line, we have forgotten that that's who we really are. In adversity, with lack of resources, our ability to come up with innovative solutions. And so I think for us, when we reflect back on that, where during that mission, we needed to do multi-layer insulation, which is like a thermal blanket for the spacecraft. We didn't have the resources to import an engineer to help us do that. We did not also ourselves know how to do that. And so we looked it up in a book and we thought, okay, this is roughly what needs to happen. And then, in fact, one of our employees, he was like, well, it's like stitching, right? So we're like, all right, well, we'll pick up. And literally, it was a yellow page. We picked up the yellow page and we're based in Botany. And so we called Philip from Alexandria, who's just, or MAITRI, just down 2 suburbs down. And we're like, come on and have a look. And he walked in and just like a person who works with that kind of production, he sort of looked at the spacecraft. He didn't do any exact measurements. He just sort of, looked at it, measured it, and went, all right, this is something, came back a couple of weeks later, and he had a beautiful MLI wrapped around the spacecraft. And down the line, we had one of the NASA people come down and sort of looking at the entire integrated spacecraft. And they said, look, this is the best looking MLI they have seen because it fits perfectly. And so from our perspective, right, we had a problem to solve. We had constrained resources. And somebody in the team just had to think innovatively about solving that problem. And I think that's just the nature of who we are as a people here and who we need to be as a people here. And so I think for us, that was great. I think there are so many more anecdotes like that in what we've done over the last 2 years.
Wonderful. So I read that you're eventually, this is perhaps some time down the track, looking to, if things go well, build hundreds of Vipers a year at OF1. What would that look like in practice if the drumbeat's going and you're manufacturing at decent volumes for this kind of product? How do you get there and what does it look like?
Can I jump in on this one, Raj? I think first to contextualize that for the audience, it's important to understand that there is demand, right? So it's like you wouldn't plan to manufacture this, but I spend a lot of time talking to governments in multiple of our allied and partner countries. And, we're getting pushed to think about how do you scale this up very, very quickly? How do you build these in the hundreds, if not thousands by end of decade, early next decade? So OF1 at UTS Tech Lab will let us build up to 20 a year, 5 in parallel. And we have plans and a blueprint being developed for a factory that would enable us to build 100 plus per year here in New South Wales. That blueprint could be then used to sort of build pods of these to manufacture in other countries or here in Australia. And then we're now thinking through the supply chain implications of that. And I think one of the really, really important aspects of how we're thinking that through, and I want Raj to build on this when I'm done, is the importance of the vertical integration and the ability for that to remove the price from the spacecraft, which then means that the demand goes up and therefore the volume goes up. And if the lifetime of the satellite on orbit is lower, then the equipment needs can be different, and you can then leverage the normal advanced manufacturing or supply chains in Australia. So, people providing into the automotive industry and others can then start to provide into us, and it builds real demand and scale, which I think is an incredibly important thing for people to understand, because people often think space is 1 or 2 or 3, exquisite and expensive, not hundreds and hundreds per year, driving real economic complexity, advanced manufacturing impact.
And Raj, did you want to add anything?
Yeah. When we think about the demand, where we're seeing the demand grow both commercially and from national security globally with US and allies on this kind of capability. You've probably seen a lot of news coming out of the US for Golden Dome and this kind of capability being put into orbit. I think what traditionally has been done to build systems like this has been, let's build one perfect one first. And then when it works really well, then we will build 100. And I think our approach is slightly different, because I think when you build one perfect one and you want it to work, you are ensuring that the risk you take is zero, and hence the cost structure you build into that vehicle is you need all of that to work. So the supply chain decisions you're making is highly performant, very risk averse. Our view is to combine the fact that we want to build hundreds of these, and that is the ultimate objective. And yes, initially, some of them might fail, but overall, you're choosing the right supply chain from the beginning, and hence keeping your cost structures really low to address the demand at the price point you want. And so I think as you start to think about this, you think production first and supply chain first to say, how do we build an ecosystem that can help us build this kind of capability at this price point so we can address the demand with appropriate margins? And in doing so, we are starting to take a very different and almost a counterintuitive approach to traditional aerospace systems, where all your focus is the best parts so that the first one succeeds or the first three succeed. Our approach is you start producing them, and Starlink's done this, and Amazon Web Services has done them in the early 2000s, is you look at system capability. You produce 10, and if 8 of them work, you still get more capability per dollar than you would get with one perfect one. And so I think taking this very different approach to manufacturing, and this is why we are now starting to think about OF1, what does that mean? We're already starting to think about, if you're producing this capability at 100 a year, what needs to happen today to make that happen? Rather than that being an afterthought after the next 3 have been in orbit, which might be, 2-3 years away.
Sure. I wanted to ask one further thing. You mentioned demand, of course, a few times in a few different contexts. What will you be selling? And tell us about your business model to sustain yourselves as a company. I've read that you're looking to do inspections as a service, potentially, or maybe looking to sell Optimuses outright, but I just don't know. Tell me about your plans in that regard, please.
No problems. Can do. I think fundamentally we're in the business of manufacturing spacecraft at volume and building the software that enables them to be defined and sold, which we call Solstice OS. The spacecraft is called Optimus Viper. Between the two of those, they form a orbit side assist solution. Now, that can be sold in a number of ways depending on who the customer is. And we see the customer set for us is across our allied and partner countries, so the US, NATO countries, the UK, India, Asian businesses are all potential opportunities. And then we think of that as national security, civil government, and commercial. Now, national security are probably going to want to buy hardware and software and do what they want with it. As you then start to move into civil government and commercial use cases, they might want to buy a service from us. So, where we start, I think the first customer is a national security customer buying systems, hardware plus software, moving to civil government that might buy hardware plus software, maybe a service as well. And then with commercial, we really want to have our own orbital network of spacecraft. And if someone wants an inspection on an object of interest, whether it be a satellite or some space junk, we can zip over there quickly, economically, give them the data that they want to get, very high fidelity data about that. So we see a building roadmap in our commercial model over time, what we're selling. But this all comes back to what we want to be famous for and the best in the world at is fast, economic on-orbit response, which means we have to be the cheapest, best spacecraft to deliver that, and the best software that enables those spacecraft to be defined and that network to be controlled and that response to be optimized.
Okay, and the next thing I wanted to know about was the recently unveiled Scintilla engine. Unfortunately, I got tied up with work and couldn't make it to the launch day, so I have a few questions and a bit of curiosity about what was unveiled. Tell me about the engine itself, how many pieces it was made in, what alloy perhaps, was it made by a contractor? I don't know that you have laser sintering 3D printers in-house. What did processing involve? All that kind of stuff about making it, please.
Yeah.
Before Raj jumps in, can I just make one very quick comment? Because I found myself at the US consulate in Canberra on Tuesday night at an event, and it was one of my proudest moments because someone from the consulate came up to me and said, "George, I've been tracking that Scintilla engine. That is incredible work. Like just mind-bogglingly incredible work." And I was like, wow, that's really cut through it. Not being an engineer who's been involved in the manufacture of it, I was like, wow, that is a really amazing moment in the journey for me. And on that, I'll hand over to Raj to actually talk about what it is.
Yeah, so look, at the heart of what George was talking earlier about this low cost, rapid response on orbit is our ability to maneuver, right? And our ability to maneuver is really driven by propulsion. And at the heart of propulsion is an engine. And so for us, the building the engine for Optimus Viper has always been a core part of vertical integration. When we looked out initially to buying this capability, we found this capability was prohibitively expensive and the supply chain was not scalable. And so we really thought about how do we bring this in-house? And so we have got a team. We put together a team of 3 people. We have a test rig, which is in a 20-foot container up in Queensland, parked on a private farm where we are doing the tests. And we started working on the design of the engine. And very quickly, by being practical, by really being focused on testing, we tested Scintilla, which is a 50-Newton engine that basically provides propulsive capability for our spacecraft. And the initial version was machined, right? We didn't want to 3D print it before we actually understood how to quickly get to the design that would work. So the idea that we could very quickly go down to the workshop, make a change, and then bring it back and then test it again was at the heart of it before we went to 3D printing. So first we tested the machined engine. And once we knew that that was working really well, then we iterated on the design to 3D print it. Now, currently we're using an external partner, a 3D printing partner to produce it. But what it's done is this exercise has helped us quantify our requirements as far as the 3D printing capability in-house. So now that we know that the machine engine worked really well, we have 3D printed engines qualified, now we can start to think about procuring capability in-house to even further make that whole build test cycle faster. And so we work with partners on the 3D printing side currently, but for us, Scintilla has now given us almost 10x reduction in price if we were to buy it from the market. And that's exactly the type of vertical integration and local capability we want to build, where something that would have cost us $1 million will cost us $20,000 a flight. And so being able to reach that and then being able to build that capability here in Australia is super exciting from our perspective.
Can you say a little more about testing that had to take place on the engine and what it's gone through so far?
Yeah, so look, we started testing late last year. And, the initial testing was just, will this thing ignite, right? And will this thing burn for 1 second? Will this thing burn for 20 seconds? And our approach to testing was push it to the limit, right? We were not targeting a certain performance. We were like, we're going to push the design to the limits. And what we found is that the initial design got us much more than what we were hoping for. And in some sense, getting it to test very quickly. So designing it, but very quickly getting to test meant that we could now start to understand how the engine was going to behave. And so for us, testing started with a little, what we call a burp test, where we're just like, is this going to ignite? It did that. Then 20 seconds, then 30, then 40, then 65 seconds. The total burn of the last single article of the engine was 1,200 seconds with minimal sort of degradation of the engine, which was exciting. Lots of restarts. So the ability to stop and then restart in orbit is a very important one for us. And so we've been running it through a whole campaign of different scenarios that we expect in orbit, where a mission might require it to start 30 times, then stop, then start another 10 times, for example.
And what of the propellant? What makes this go?
Yeah, so the current propellants we use is ethane and nitrous oxide, so laughing gas and, a sort of cousin of propane, your barbecue gas. And so we found that it was simple, it was green, it was well understood, it was safe because people know how to handle it. We didn't want to choose a propellant that our engineers was completely foreign to. So I think ethane gives us the right balance of performance, safety, performance characteristics. And we see this combination now being used by a lot of companies in the US as well. So it's a good combination that simplifies the overall architecture as well because it's self-pressurizing. So it's brought a lot of simplicity and ease of handling for us.
Cool. And so we've been on the line for quite a while, and I won't take up too much more of your time, but I wanted to ask a couple more questions. One of them was, a little bit of a sketch on the remaining work to do before MAITRI goes ahead. What do you, I don't know if you're racing the clock in some regards, but what's some of what happens to get us from here to there?
Look, with any space project, you're always racing the clock. So we are deep in design at the moment. We hope to be at a critical design review very shortly. And very quickly after that, we will start assembling and integrating the spacecraft. And the current sequence for the mission is that we will build a spacecraft here in Sydney, integrate our partners, Australian partners that will be going on to that mission here in Sydney. So that's HEO and several other partners that will be on the mission. And then we will ship the satellite to India, where we have a local partner that we're working with. They will then put on the Indian payloads on the satellite and do a final round of testing before it ships off to the launch site in southeast of India before launch in the middle of next year.
And this is a question that was probably best asked at the beginning, but through the magic of audio editing, we can put it back there where it belongs. I'll just ask you now. So how many people within the company at the moment? What does your sort of staffing arrangement look like? Because you're at a few locations, I believe.
Yeah, so we are 50 people across 3 locations at the moment. And so in Sydney, we have about 40, and the rest are spread between Adelaide and India in Bangalore.
Raj, you forgot one person. We do have a person on the ground in the US in Washington now.
As of 2 days ago.
I'll forgive you for getting that one because it's a recent ad, but it's an important strategic ad for our activities because this lady will be overseeing what we're doing in the US and also giving us some bandwidth to cover the UK and Europe.
Right. And so the last question I wanted to ask you is the standard closer. And that's what's an issue within manufacturing that isn't getting the attention it deserves in your view?
Can I take this one first, Raj, because I've just come back from a trip through Canberra. And, I think manufacturing and building things is fundamental to the future we want to build in this country. Like to the future made in Australia, we need to get good at manufacturing things. And we are currently constrained from a capital perspective in this country. I think we've got to get the policy settings right to encourage the type of manufacturing that we're trying to do. And I think it's the right type of manufacturing to be doing in this country. And those policy settings and signalling from government need to quickly bring capital in to let us capture the opportunity that presents itself. And I will acknowledge the NRF and the IGP are great instruments of government, but I think that without spending a lot more money, the government can do some policy things and some signalling that will really drive capital investment to unlock the manufacturing opportunity we'd love to see flourish and thrive here.
I'll add to that. I think in addition to what George just talked about, I think as a country, we have a lot of ingredients for manufacturing, right? We've got some great companies doing great facilities, great knowledge of manufacturing techniques. I think having an end goal, having a mission, a project, an industry to focus on. I think what we are championing from our end is that space production, given that we're going to depend more on space in the next 5 years than we do today, that space production can provide that commitment to building an asymmetric capability that Australia can own to build all of these great ingredients and push those ingredients into programs that help build that space production capability. And that's not just us. There are a number of companies in space that are starting to think about how to mass manufacture. So I think the program of work, the demand, the commitment to an objective, I think is as important as policy and capital being applied towards it, because it really sets the risk appetite for what we as a country are willing to invest on.
Well, guys, I appreciate your generosity with your time and your willingness to share quite a bit of info about what you've been up to so far. It was lovely to meet you both. Thank you, George and Raj, for joining us on Manufacturing Conversations.
Thanks very much for having us, Brent. Really enjoyed the chat.
Likewise.
Thanks, Brent.